Welcome to this explainer. Look, today we have a really exciting goal ahead of us. We are going to look at liberating your coding workflow entirely from the cloud. We'll be breaking down a comprehensive guide by Dr. Sebastian Raschka on exactly how to build a fully local, highly powerful AI coding agent stack. So if you've been relying on cloud-based AI tools to write, debug, and manage your code, get ready to take back total control of your environment.
Okay, let's dive into this with a fascinating insight from Dr. Raschka himself. He points out that anything faster than 20 to 30 tokens per second is perfectly reasonable for local agent work. Now, why is that specific number so important? Because that is roughly the exact same speed as GPT 5.5 running in its high reasoning mode. We have literally reached a point where private, open-weight models have effectively matched flagship proprietary speeds. And the best part, once you have the hardware, they are essentially free to run. To get us there, we're going to follow a very clear architectural blueprint, tearing down and rebuilding this stack layer by layer. We'll start with the case for local agents, power up our underlying LLM engine, make a mandatory pit stop for auditing and safety, choose your coding harness, and finally, benchmark speed and performance to stress test the whole setup. Let's get right into it. Section 1, the case for local agents. Why go offline in the first place? Let's explore this massive paradigm shift. It really comes down to the clear, objective differences we're seeing right now. With proprietary agents, you're constantly dealing with shifting limits, right? You've got monthly subscription costs, background telemetry, quietly sending your private data off to Anthropic or OpenAI, and the very real risk of API throttling, which, let's be honest, we've all seen happen recently. On the flip side, local agents offer incredibly predictable fixed costs. They are completely offline capable, which is perfect if you're working on a flight or just off the grid. And most importantly, they offer 100% data privacy. Literally, no one sees your code but you. Moving on to Section 2, powering the LLM engine. This is all about the foundation of our stack, the actual reasoning engine that's going to do the heavy lifting. You obviously need a robust engine here, and right now in the 35 billion parameter weight class, Qwen 3.6, 35B A3B is widely considered the absolute best in class. It uses a hybrid attention architecture and just dominates most benchmarks for its size. Now, if you want a strong alternative, Cohere's North minicode is right up there with it. Keep in mind, these models are pretty hefty. They require around 30 to 40 gigabytes of RAM to run efficiently. To actually serve them locally on your machine, we're going to use Ollama as our serving engine. It provides incredible plug-and-play efficiency and easily exposes an OpenAI-compatible API endpoint right on your local host. Section 3, auditing and safety first. It's time for a little bit of pragmatic paranoia before we hook things up. So the crucial point is this. While an LLM running in Ollama is basically just an isolated engine sitting on your computer, the coding harness is the car itself. It's the software that actually interacts with your hard drive, runs terminal commands, and edits your files. So you absolutely have to be careful about what you are running and where you are running it. Because the harness has all these autonomous powers, we really have to practice that pragmatic paranoia I mentioned. You must perform a blast radius audit before you install a new harness. Check for data egress. For instance, some open source tools will actually still send telemetry to remote servers, like Alien in the case of Qwen-Code's default settings, unless you manually go in and disable it. You also need to verify exactly how it handles file read and write boundaries, and assess its vulnerability to prompt injection from malicious code repos. Honestly, running these tools in a sandbox or a separate virtual environment is highly recommended. All right, Section 4, choosing your coding harness. Let's look at the agent's chassis and how we actually connect it to the engine. Just to be crystal clear on the definition here, the coding agent harness is the operating environment surrounding the LLM. If the LLM is providing the raw brain power and reasoning, the harness is what provides the infrastructure to translate that reasoning into meaningful, tangible action inside your local project folders. It literally gives your reasoning engine hands and eyes within your system. It autonomously reads your workspace files to gather context, it makes direct code edits across multiple files, it can run shell commands right in your terminal to test its own work, and it verifies if those changes actually fix the bugs or pass the tests. It's the whole shebang. For your local stack, there are 3 primary contenders that we can easily plug our local Ollama API endpoints into. Qwen-Code is a fantastic open source option that's optimized heavily for Qwen models. Then you have Codex, which provides an incredibly efficient open source command line interface. It kind of acts as a universal harness. And finally, there's Claude Code. Now, while it is proprietary and closed source, it's very widely used, and you can actually route it to use your local Ollama models with just a simple launch command. Section 5. Benchmarking speed and performance. Now for the fun part, let's stress test our newly built stack.
This brings us to the single biggest question every single developer has before they commit to a local stack. We know it's private, we know it's free, but is local AI actually fast enough to replace a cloud subscription for your daily coding workflow? Well, the answer lies in this magic number right here, 30 tokens per second. Remember, as we established earlier, 30 tokens per second is the exact speed of GPT 5.5's high reasoning load. If we can hit that on local hardware, the workflow feels completely seamless and totally professional. And this brilliantly illustrates that we are fully clearing that professional performance bar. On a DGX or a high-end Mac Mini, both Qwen 3.6 and North Mini Code comfortably process 50K context windows at 30 tokens per second. The smaller Gemma 4e 2B model even hits 40 tokens per second, though, it does struggle a little bit more with complex tool calling. But wait, model speed is only half the equation here. Notice this really surprising data point regarding the harnesses themselves. When tested on the exact same tasks, Claude Code burns through nearly 20,000 input tokens. Qwen-Code uses about 12,000. And Codex, it achieves the exact same 5 out of 5 task success rate using only 10,000 tokens. Claude Code is just repeatedly feeding massive amounts of context history back into the model on every single turn. So what does this all mean? Lower token overhead literally equals faster execution. If your harness uses 50% fewer input tokens to solve the exact same problem, like Codex does compared to Claude Code, your local engine will literally complete the workflow twice as fast. Pairing a really fast local model with a highly efficient harness is the absolute secret to an incredibly snappy setup. Okay, let's move to a super high-value pro tip for those of you with multiple machines: the Mac to DGX bridge setup. Because if you have a lightweight laptop and a heavy server, you don't actually need to run the engine and the harness on the same device. You can set up a simple bridge, and it's so elegant. Step 1, quit the local Ollama instance on your Mac. Step 2, open your terminal and create an SSH tunnel that forwards your Mac's local port 11434 directly to the Ollama port on your heavy DGX or Linux server. Step 3, just run Codex or Qwen-Code natively right on your Mac. Your laptop handles the lightweight harness file operations while your heavy server silently acts as the massive reasoning engine in the background. It is a brilliant, highly efficient workflow. We've covered the engines, the safety audits, the harnesses, and the genuinely incredible performance benchmarks of modern open-weight models, leaving us with one final provocative question. Are you ready to cut the cord and take back control of your coding stack? Building your own local setup isn't just about saving a few bucks on subscriptions. It's about complete privacy, total offline capabilities, and experiencing the genuine fun of private, untethered AI. Thank you so much for joining me for this explainer, and hey, happy coding.